This video is on hydration and dehydration reactions. I'm sure if you were ever outside when it's very hot out, people have said to you to stay hydrated. When we say to stay hydrated, we are saying to drink fluids or drink water. So a hydration reaction is when you are having water reacting with an alkene. Again, an alkene is a carbon double bond carbon group in the presence of a catalyst to form an alcohol. So hydration, we will have an alkene and we will form an alcohol. Dehydration is the opposite of this. This is when you will eliminate an H and an OH bond, that is your water right there, your H2O, from an alcohol to form an alkene. So it is the reverse process. We will get rid of the H and the OH, and then this line that I'm highlighting in blue will become our alkene double bond. So starting with hydration reactions, the H and OH from the water bond to each carbon atom of the double bond. And then that double bond becomes a single bond. So you can see here, this is the point of interest, these two carbons, a carbon being here and a carbon being here. And the H and OH will attach to one of those, and then the double bond will become a single bond. Now, how do you know which side the H and OH goes on? That depends. So the OH will go to the carbon with fewer hydrogen atoms on it. So if we're looking at this diagram here, here are the carbons of interest because that is our double bond. Carbon 1 has 2 H's on it, and carbon 2 only has 1 H on it. So the OH is going to go to carbon 2 because it has fewer H's. And then the H will just go to carbon 1. Notice what happened to the double bond here. It went from a double, an alkene, to an alkane, a single bond. Now, what if you have the same number of H's on a carbon? So if you look at this reaction here, here are our carbons, and notice that each of the carbons has one H coming from it. So you will usually see a carbonyl group, so an O double bond C, that is next to the carbon-carbon double bond. Here you can see it is blocked off. That directs the H atom to the double bond carbon closer to the carbonyl group. So the H will be on the C closer to the carbonyl group. So if we highlight this yellow, this C is closer to the carbonyl group, so that is where the H is going. I highlighted the wrong H. That is where the H is going. And then your other C on the left here, that is where your OH will be going. So again, we have our alkene plus our water, and we get our alcohol. It's an alcohol because of this OH group here. Here's a hydration reaction, another example here. So we have a fatty acid thioester. Look for your double bond here, not your carbonyl double bond group, but the double bond that I just highlighted. Again, your H wants to be on the carbon closer to the carbonyl group. So that is why the H is on that carbon, and then the OH is on the other carbon. So if you have the same number of H's, that's how you decide. So dehydration now, again, this is the opposite process of hydration. You are going to lose water, your H and your OH, from your alcohol to produce an alkene. So you're going to find where the OH and H are on adjacent carbon atoms, and water is going to be one of your products. So you can see down here, water is a product, and an alkene will be a product. Your alcohol is your reactant. Once you take the H and the OH away, in this case it's here and here, you are forming a double bond between those C's to get your alkene. So this right now is a single bond. Notice on the product side, it is now a double bond. And then don't forget your water molecule. Okay, again here on the left-hand side, we have our alcohol. Here are our adjacent carbons with our OH and our H. We're going to take them off and form our water. And those carbons that we circled, we are getting our double bond there, which is right here. If you have an H adjacent to the carbonyl group and an OH group 2 carbons away from the carbonyl group or next to the H, they are eliminated. So this again is the same in reverse. Remember, for hydration, we added the H that was next to the carbonyl carbon. Now we're going to eliminate that H and the OH. And you get your double bond here, and you get your water from your OH and H. In step 7 of the citric acid cycle, the reaction shown below occurs. So you can see what we have going on here. Take a look at this reaction. Is this a hydration or a dehydration reaction? So notice a couple things. One, we're adding water to this. So that's one reason why I'm saying it's a hydration reaction. The other is, notice on the left I have an alkene. Then I have water. And then on the right I have my alcohol. So that is the formula for hydration. So this is indeed a hydration reaction. Next part says, identify the OH group and the product structure that came from a molecule of water. It looks like I just circled that in red here. I'll highlight it in green now. That is the OH group from the water molecule. It does ask us, it says, what other new bond has been formed? Here is your H that was formed. Notice on the left-hand side, nothing shown there. And the last question says, what functional groups are unchanged in the reaction? So if you look on the left, these two are still here on the right, and they're called our carboxylate groups. So they are unchanged in this reaction.